Uh, so as said, so I'm coming from Josef Stefan Institute, Artificial Intelligence Department. Josef Stefan Institute is well, biggest institute here in Slovenia for natural sciences. We are like 1,000 people. Well, the country is of similar size as Latvia, right? So this is pretty much what we have, right, in terms of natural sciences, but still it's pretty big concentration of people. And out of this 1,000 people, we are like 200 people working in the field of artificial intelligence. Okay, let's go to the topic. Let's first view so how to understand artificial intelligence in an intuitive way, right? Now, what you see here on the picture, right, are just nice pictures, really, right? Nice pictures which everybody recognizes. So this would be mountain and snowflake and brain and geographical map and so on. So what does this tell us? So nature in general is organized in a structure. So nature is not random, right? And the way how nature is organized is mostly this self-similar, right? So it has this nice patterns which we all enjoy when we go outside and then when we look nice pictures and so on, right? And what science, not just artificial intelligence, but what science in general tries to do. So science tries to uncover this hidden structures, hidden organization in the nature. So in general, we can say that science is not discovering something new. It's more like uncovering what is out there and what's already exists. So science is not really something, it's not doing any kind of miracles. We just uncover what's out there. Now, artificial intelligence is just part of the science, right? And now the next slide. Again, we see some nice pictures, right? But this time, these pictures are not taken from nature. This is now artificial intelligence, which is mimicking nature, right? So artificial intelligence tries to check pictures like this, tries to learn the patterns, right? And once we have patterns, then we can generate, let's say, pictures or some other kind of objects which look like nature, but they are not entirely, right? So here we see, okay, this would be the Facebook network within Europe, then human face, right? So this face doesn't exist. This is automatically created, right? Human face is again just a pattern, right? With small differences, but it's just a pattern. So this is like generated. Or tree, right? Generated from the way how computer learned what the tree is and so on, right? Now, how we describe these patterns? This is very important question. So how to describe the pattern? So usually we use some kind of mathematical formulas. Now, if we graphically represent these formulas, then we get this kind of structures. But not everything can be drawn in such a nice way as we see here, right? Now, these mathematical formulas or these formalisms, right, which we use, usually this would be algebra or logic. This is pretty much what artificial intelligence, but also the rest of science like physics and mathematics would use. And why this mathematics is good? Because it's pretty strong language how to describe patterns in nature, right? So that much for introduction, right? Now, let's deep dive a little bit into AI. Um, so artificial intelligence is around for a long time, from 1950s, right? For at least 70 years. But it really started as more like as a movement between mathematicians and computer scientists, and then in 70s, 80s really got a little bit more popular. Then the big breakthrough were 90s, right? In 90s, there were somehow, this was roughly the time when we were able to store data on a little bit bigger machine, when these prices of computers were going down. And this was also the time when the area called data mining appeared, which is one part of artificial intelligence, right? And then the big difference was really September 11, 2001, when I remember when these twins in New York were crashed. So this was a moment where American government and also the rest of the world pushed really a lot of money into the area of data mining and artificial intelligence. And this was like, then things went just up, right? Which we will see maybe at the end on one of the slides. So what was the difference, right? So artificial intelligence in 1980s was mostly dealing with logic, how to represent the world and so on, and a little bit of data analytics, but data was not there because computers were really weak and it was really hard to collect data. Now, if we let's say make fast forward to today, what's the difference between today and back then, right? So computing power. So computers are like 10,000 or even more faster than in 1980s or 1990s, right? So one single iPhone or smartphone which we buy today, it's like a supercomputer back then. Like the most expensive supercomputer at the end of 80s is roughly corresponds to iPhone today, right? So this is one huge difference. Then storage, right? We can store data today. So today we talk about petabytes. So everybody has computer with gigabytes. Back then in 1990s, we didn't even know the word gigabytes, right? So back then we were talking about megabytes or tens of megabytes and so on. But today every kid has a gigabyte, or every mobile phone has, I don't know, 100 gigabytes and so on, right? And then one very important thing was also open source software, right? So back then it was not a culture. If you wrote a software, it was not a culture to share it with others. Today, most of the software actually it's open source, and you can always take what somebody else did, right? And this made a huge difference, really, right? Then, of course, one important element was also development of algorithms, right? Now, not that these algorithms were really today's artificial intelligence algorithms are very different from the ones which we had in 1980s or 1990s, right? It's just that in combination with this huge computing power, storage, and in particular data availability, now these old algorithms, old ideas really came into the power, right? And today, the most progressive part of artificial intelligence is this, what we call deep learning, right? Where computers learn from data, right? So this was back then simply was not possible, right? It was computers were too weak, and we didn't have data available. So this made a huge difference, right? Now, if we try to position today, right? So what is possible today, right? For instance, an undergrad student of computer science, which can do some programming, maybe not even too much, right? So some basic knowledge of programming can basically produce results which 10 years ago or 15 years ago, the whole scientific community was not able to do. So this is what happened in the meantime, right? So what would be kind of a simple recipe if you want to do today, or many people are actually doing this, if you want to do the modern AI today. So you go to web, you download free deep learning package. I will show one a little bit later. You buy a computer for, I don't know, 1,000 euro or 2,000 euro, doesn't really matter, right? Get some data from somewhere. You can download the data on pretty much anything today for free. And you drop this data into this software and you solve the problem. So this is it. Very simple recipe. Everybody can do it. Usually it's like maybe 10 or 20 lines of code, not much. Of course, it can be bigger as well, right? But already with 10 or 20 lines of code, you can do a lot, right? And this is today solving problems which were simply not solvable like 10, 15 years ago, right? So here on the bottom, we have like 4 of these very popular packages, but there are more, right? So the first one is from Google. Second one is from Microsoft. I think this one is from Amazon. This one is from Facebook. So companies are kind of competing almost which company would provide you with more free software, right? Which again was not the case in the past. Okay, just before going to this live demo, right? Another view to artificial intelligence. Maybe it will sound a little bit philosophical, but it's very true. Artificial intelligence algorithms function along two key dimensions, right? So first thing is, what kind of phenomena in the environment, in the nature, or in our environments do we try to detect, right? This phenomena could be even known to us, to humans, or can be even unknown, right? So computers nowadays with AI can discover phenomena or elements in the nature which are just not known to us. So we can learn something new through this algorithm. So this is phenomena dimension. And the second one is how we describe these patterns or these phenomena, right, with algorithms. And again, we can use languages like which people understand, or languages, so like mathematics and so on, right, which humans cannot understand. It's just too complicated, right? So these are two key dimensions. Now let's go to the this table. Here you will see what made really the difference of this AI which we are using today. So in the past, right, so mostly in statistics, data mining, machine learning, and other fields, or even physics, right? So we were mostly discovering known phenomena. So things which we kind of knew, we just wanted to rediscover, model, and so on. But also unknown phenomena. Some unknown phenomena would be also possible. But what made the huge difference is that we were describing this known and unknown phenomena with known language, the language which people understood. So this would be simple analytical language, like analytical formulas, linear formulas, and so on, right? So this is what we know from physics, from mathematics, and so on. So this is like a language known to humans, and we discover known or unknown phenomena. Now, what made a huge difference, right, in the last 10 years? So we let computers to invent their own language which is suitable for the problem which they are solving. And this made such a freedom to computers or to algorithms that they started doing, solving problems which were just not solvable with these languages which were constrained by our understanding, right? And this basically, it's what happened in the last, I would say, 10 to 15 years, more like 10, right? More like 10 years. And with this, the fact that computers started using languages which we humans don't understand, but they are perfectly understandable for computers, this made us solve, for instance, problems like, for instance, probably you heard that the computers now are so much better in chess, in the game of Go. So these were some of these early successes, and many more, right? So this was possible because of this. So this made a huge change. This is basically something which nobody tells you, but this is really conceptually fundamental reason why AI is today so strong, right? Okay, let me skip this slide. And let me show you how, before just going back to this slide, I was showing here some of these most well-known packages which are used today for AI, right? So I will now show you this the package called Tensorflow. This is done by Google, and I will show you in practice. So this TensorFlow, right? TensorFlow, basically it's a package which you can download. So you can go to, let's say, TensorFlow. So if you open web, you go to tensorflow.org, and you would get website where you can basically download the whole thing. You have tutorials, everything, right? Plus you have tons of data, examples, and so on, right? So this is the package. Most of you probably never heard of this TensorFlow, although you are using this TensorFlow every day, many times. Whenever you go to Google, whenever you make a search on Google, you use TensorFlow. TensorFlow helps you, helps Google delivering results to you. Or whenever you do, I don't know, speech recognition, whenever you do machine translation and so on, it's always TensorFlow in the back. Whenever you use Google services, right? But also some others, right? So TensorFlow is about, it's implementing these neural networks. So neural networks is one simple mechanism which you will see, which is not very complicated to understand. So the idea is old. It's from 1950s. I think first people were some Russians actually, which got the idea of this neural networks, but this idea was really not picking up for a long time until like 10 years ago when because why it didn't pick up, because it was so intensive algorithms which were simply not useful on weak machines, on non-powerful machines. Today we have really strong machines, especially these GPUs, graphical processing unit machines, right? And this makes a huge difference, right? But to skip talking, let's go to the this demo. Yeah. 5 minutes, yeah, this is exactly what I so let's go to TensorFlow. So what you see here, it's a small neural network, right? And we will be solving very simple problem. But the same type of problems we solve when we are doing image recognition, whenever we do machine translation and so on, right? So this will be, what is the problem here? So here we have blue points and we have orange points. And now the task for this neural network is now to separate, to find the function, mathematical function, which separates blue points from these orange points. So sounds very simple. Actually, it's not hard problem, right? So now you see how, so now this neural network, which you see here in the middle, it's a mathematical function. And each of these boxes here is one neuron, right? And what Tensorflow is doing, basically it tries to find parameters, numbers, tunes this model, right? To that degree that it separates blue points from orange points. Okay, this was kind of a simple problem. Now let's make the problem a little bit harder. Now you see here we have orange points like in a spiral and also blue points in a spiral. And now we say, okay, neural network, try to separate this and won't succeed. So we need to increase. So this neural network is like a brain, right? So now we increase the size of the brain a bit, right? So we add more of these neurons, right? And now we say, okay, neural network, try to separate this. Now you will see now it's doing better job, right? It's better job, but still not really good, right? So we need to help with a few additional inputs. And now if we wait just a little bit, now you see that this increased neural network kind of managed to separate and it's still working, right? What you see here is the error, right? So lower this curve goes down, better the model, right? And in principle, this now it's kind of solved, right? Now, what's the difference from the example what we see here to the actual use of neural networks? So here we have each point here lives here in 2 dimensions. So each point here has X and Y, right? Now the difference is only that when you do machine translation, when you do image recognition, that it's not just X and Y, it's not just 2 dimensions, but usually we would have maybe 1,000 or 10,000 dimensions. And that's the whole difference, right? So each point would have not just X and Y, but would have many more of these coordinates, right? And that's the whole thing. Now, using this, in principle, it's free software. You can download, drop in data, and in principle, you can do many things. So this is like, well, quick introduction to AI with this example. So my main point, so I have just 1 more minute. My main point was, so AI, it's here today. It's not very complicated. Maybe it looks like complicated, but it's not, right? So these neural networks, for instance, as one of the core algorithms, it's something which even high school students could easily understand what's happening there, right? So it's free, it's downloadable, and if you're interested, you are more than welcome to try and use this, right? Thanks very much.
Hvala, thank you. And if you don't mind, I would like to interact with your speech with a short question. And it could be following. For you personally, which has been the biggest ethical challenge for your work field during the last year in terms of artificial intelligence or related topics?
Yeah, ethical challenges. So I work with OECD, UNESCO, European Commission, and so on. So I I'm involved in many of these discussions where these policies are being formed, right? So now we discuss a lot about ethics. Now you asked me what was my personal biggest challenge, right? For instance, whenever you touch personal data, right? You see things. So personal data would mean when you see data about people, what they do, how they interact, and so on. And there's a lot of data of this kind available. Whenever you start analyzing this kind of data, you see more than you want to see, right? Sometimes you know more about the person that the person itself knows. You see like hidden trends, inclination, and so on. And this is usually the biggest ethical challenge, I would say, and we try to keep away ourselves from this kind of personal data. So this is one aspect. And the second aspect, it's not just about humans, us individuals, right? It's also about our community life, right? And analyzing like data like Twitter data or maybe something similar, right? You learn about the society more than you would think, right? So you see all these hidden layers of society, of the life of the society, and this also presents also some kind of ethical questions, I would say.
Thank you very much. Yes, it's true. I agree that the personal data has always been an issue. Indeed, for example, we all remember also the Facebook scandal a couple of years ago, and these examples, there are many more out there. Thank you very much, Mr. Grobelnik.
Thanks. Thanks a lot.